So in this video I'm going to discuss about the SHM simple harmonic motion. As you guys all know that in the previous video the Hooke's law equation was F is equal to Kx. So after that the main equation was got remained by mistake. So as you guys all know F is equal to what? Ma is equal to the minus Kx. Minus was there because of the position, the body basically always after the extreme position it comes to the mean position, so that's why it is minus sign. Alright, so if you want to find the acceleration, so what we'll do, acceleration is equal to minus k upon m is equal to x. So this is a constant, so constant, which means there is a directly proportional sign, so a is directly proportional to the minus x, which means that more acceleration, alright, more acceleration, there will be the more displacement. So this is the final equation of the Hooke's law. So Hooke's law is basically valid on the SHM. It is showing the SHM, which is simple harmonic motion, which means that acceleration is directly proportional to the displacement. Alright, so SHM is what? SHM is also that this is a periodic motion in which acceleration is directly proportional to the minus x, which is the displacement. So it is a oscillatory motion or periodic motion, which means that, what does it mean? It means a body repeating after a body motion repeating after equal interval of time. It means that, for example, I'm having a simple pendulum like this. If there will be the force, so it will move, or it is the mean position, it is the extreme position, So for example, I'm having the 2 seconds. It is having a 2 seconds. That for example, I'm having the time that is 2 seconds. So what will happen, that this one, for example, I'm checking this position. So in 1 second it will go here, and in 1 second it will go here, and here it will the 2 second will be complete. So here a body will repeat equal interval of time. Understood? So you can take the example of the earth. Basically, you can say that earth basically rotate around the sun in 365 days. So this is the time, that is the equal interval of time that cannot be changed. Alright, so these are the example of the periodic motion. So periodic motion is having a restoring force, which means that after the body moving at the extreme position will come at the mean position. Alright, like extreme position, and after some time it will come at the mean position, which means that this is all of what? Because of the force, this is the restoring force. Periodic motion have the restoring force. The force which basically after body basically come to a mean position, that force is called the restoring force. So periodic motion have the restoring force. So here the equation is that A is directly proportional to the minus x. Minus is indicating that the direction toward the mean position, and x is what? X is the displacement, and that is what? This is the acceleration. Alright, there will be the more acceleration, there will be the more displacement. Alright, so for example, you can take the example of the simple pendulum. Understood what is simple harmonic motion? So this is the mean position at the resting condition, the rest one, this is without force. When here is a force, so it will move at this point, that is what? This is the extreme position. Alright, and if you talk about the extreme position, so their potential energy will be maximum because of the maximum height. Potential energy will be the maximum. And if you talk about the kinetic energy, at some point this will stop, and then again it will come at the mean position. So when it will stop at the extreme position, so there the kinetic energy will be equal to 0 because of no motion, and if kinetic energy will be 0, then the velocity will be also 0. Alright, but displacement will be equal to maximum, because it has covered a displacement. So that will be the maximum, 0 0. All right. Now if we talk about the mean position at resting period, so there the potential energy will be 0 because of no height. It is resting period, it is the rest point, and their velocity will be maximum. You will say that this is the resting point. Here the potential energy is 0. How the kinetic energy will be the maximum, and the so when it will come at this point, when it will come at this point, so at the end, here the kinetic energy is the full maximum, and here the velocity will be also maximum, but here it will be the before coming at this point, which means equal to the what, it is equal to the mean position. So it will be what, it will be the maximum. Alright, and here the acceleration will be equal to 0 because mean position having the haven't covered the displacement, so displacement also having the 0, and acceleration, if displacement is not there, so the acceleration will be not there, so acceleration will be also 0. So this was about the simple harmonic motion. Alright, so simple harmonic motion, it is basically Hooke's law is valid on the simple harmonic motion. Alright, so one thing I want to tell you guys, that is basically that the applications we are going to discuss about the simple harmonic motion. So that application is basically first is a simple pendulum we will going to discuss, and the mass will be attached with the spring. That application we will discuss, and third one we are going to discuss, that is the motion of a projection of a body along a circular path. That three application we are going to discuss after this video.